It's recording now. All right, team. Shh, shh, shh. Thank you. Let's see. Some terminologies. Dividend, quotient, divisor, and remainder. Which one of this, when you do 15 divided by 4 and then it equals 2 and then you have an answer, right? So how many 4s in 15? 3 wholes. And then you've got a remainder of 3 out of 4, right? I just gave you one of the words just now. So remainder. So that's one less to worry about. Which one is the dividend? Can anyone know? Hands up. Lachlan? No, but that's a good guess. Now we've got one eliminated, so you got now 50-50. Which one's the dividend? Pat? Dividend's the one on the top numerator? That's right, that's what we usually divide by, so hence divisor. And then obviously 3 must then be, so the number of wholes is your quotient. That's why, back in year 7 they say find the quotient of 12 and 4. So that means 12 divided by 4. What is the quotient? The quotient is 3. Okay. And also from last year when you learnt remainder theorem and factor theorem and then rational root theorem, you would have seen this if you looked at the notes in there. They did a proof for remainder theorem. But the Q of X there represents your quotient. So that's a way to remember it as well. Now, right here is essentially where the basis for your remainder theorem comes from. But underneath I wrote or, so there's another version that you can look at. Rearrange that equation. Instead of having the divisor on the bottom, you can eliminate it by multiplying both sides by d of x. So whatever the divisor is. And that will give you d of x multiplied to q of x. And then d of x times the fraction will just become r of x. Which then becomes abundantly clear that whatever your divisor is, if you sub in, you know how you do the remainder theorem, you find that value, you sub it into a function, and then if it's 0, whatever's left over is your remainder. Makes sense? True? So let's revise what we learnt last year in cubics. Or, well, technically it's under polynomials, but mainly you would have dealt with cubics. Let's have a look at this one. Got the answer on the side for you using a CAS. So for those who don't know how to use a CAS, you can go to proper fraction is what it is. So you go to menu, algebra, fraction tools, proper fraction, type that in, and they can do your polynomial division for you. So you get your quotient plus your remainder. But in this case, we want to do it by hand now. How do we do polynomial division again? So, yes, Lachlan. It is on the sheets. That's right. So we're going to lay it out. We want to find what is 2x to the power of 4 minus 4x cubed minus 6x. Oh, you're missing an x squared. Interesting. All right. Plus 6 and then divided by, the divisor is x plus 2. All right. Now we know from junior maths or even primary school with long multiplication, short multiplication, divisor comes out on the outside, so x plus 2. How many x plus 2's fit into 2x to the power of 4 minus 4x cubed? I'm going to put minus 6x over here plus 6. For those who did this last year, you would have noticed when you don't have one of the powers, so x squared is missing, it might help you to write in 0x squared, if that helps you. Okay? You may have learned to shortcut too. You could have done it through synthetic division, but I'm sticking to what Vika wants you to know, which is long division by polynomial division. So this is the way we're going to do it. All right. What's the first step? Can I please have, let's go with Joe. What do we do in the first step?
Write 2x cubed at the top.
2x cubed at the top. So let's write out 2x cubed. Why? Because we're asking x times what? will give you as close to 2x to the power 4. So this is what we did last year. Or you could say x to the power 4 divided by x plus 2, and you can see the x4 divided by x gives you that 2x cubed. Okay? So we're essentially saying this times this will give me now 2x4, which is great. But then remember, it comes in two terms, so you actually have to multiply 2x cubed with 2, and that gives you now plus 4x cubed. Find the difference, which means find the remainder. So we want to see how many times it fits in, and what's the remainder? Well, clearly this is going to be 0, because it fits nicely. But negative 4 minus a positive 4 gives you negative 8x cubed. And like I said, it might help you to add in that 0x squared if you aren't familiar with it. So I'm going to add in that 0x squared. And now we're doing the next thing. We drop down the 0x squared. And we do the same pattern again. So what's the next number? Can I please have Xavier? What would you put next? Very good. We've got negative 8x squared multiplied to x will give me negative 8x cubed. But don't forget, you also have to multiply the 2 as well. So that gives you negative 8. Oh, no, not negative 8. Negative 16x squared. And again, you find the difference. Finding the difference, that gives me now, we know that's going to give you 0 because double negative is positive. And then 0 minus the negative 16 is actually positive 16x squared. Same thing. Drop down the next one. Negative 6x. Next person. Tara. What goes on the top? 16x. Very good. So it's positive 16x. And then we say, all right, well, that fits in nicely. Positive 16x squares plus 32x. Find the difference. And here we go. Let's do it again. That gives me now, what's that? 0. Negative 6 minus 32 is negative 38x. And finally, dropping down the 6, I get now plus 6. And finally, what is the last one there? Let's go with Mia. Negative 38 is the only way to get a negative 38x. And then negative 38 times 2 is what? Negative, what's that? 78. No, 76. Yes. Find the difference. 0. And your remainder is 76 plus 6 is 82. So let's check our answers. Our quotient, which is up here. 2x cubed minus 8x squared plus 16x minus 38. Yes, my quotient's here. Our remainder is 82. It's 82. Remember, it's 82 out of your divisor, which is what you began with. That's the type of fraction. Our divisor was x plus 2. That's why it's out of x plus 2. Okay, so this is one of the first skills for year 11s in term 1 and 2, where it may be challenging for the first time. But after a while, I'm assuming you now mastered the skill. So that's the first part of exercise 4D, is to get used to that. Make sure you're fluent. Make sure you can do both polynomial division. If you've learned synthetic, very cool, you can use that. Remember, there's some restrictions with synthetic division as well. And then let's now go into the next page. So flip over. Let's revise some of the key things that you needed to know from last year. So with polynomials, there were remainder theorem, factor theorem, which to me, both of them are actually the same idea. And then the one that I think students last year really had troubles understanding, or even how to use or what it is rational root theorem. So we'll talk about that. Let's go back. What's remainder theorem again? So you got a polynomial, no matter what type of polynomial. That's the expression from last session, 4C. And we're saying that when you do polynomial dividend divided by divisor, and it equals to x minus a, then the remainder is p of what? Ends up if you remember. P of what? What's the notation? What are we saying? So an example is if I said it was x squared plus 2x plus 1 divided by x minus 1, as an example, then this is your p of x. and this is your d of x, then how do I find the remainder? Instead of doing the polynomial division and then find out the remainder theorem says you can skip all that by substituting in. Very good. So in this case, it would have been p of 1. So yes, you're right. This is what you'll be solving for. Rearrange it to find what x should equal to. Essentially, it's like the inverse of null factor law. Okay, so we're saying if this is a factor, well then x equals 1. We're substituting that back in here. So in the expression, this should be then p of a. Okay, so p of a, if you sub a into the expression, so all this becomes a, whatever's left over will then become your remainder. Okay, we'll do some examples later just to remind you. And then with the same idea, so if you can just sub in a number and whatever the result of the expression is, that tells us that's the remainder. Well then factor theorem says what? When p of x divided by, so dividend divided by the divisor has 0 remainder. If it has a 0 remainder, so it means that whatever number you decide to sub in, whatever a is, if you sub it in and this ends up being 0, meaning the remainder is 0, that tells me that x minus a, so the one that's your quotient, that is a factor. Okay, that must be a factor of what you divided. If it's a factor, well then it fits nicely. It's kind of like saying 12 divided by 3, 4. 4 is a factor of 12, but 3 is also a factor of 12. Okay, so because they're factors, there's 0 remainder. All right, so these two, they're pretty much the same thing. One equals 0 and the other one doesn't equal to 0. Cool, so you'll be trialing and error to find your 0. Once you know which one is a linear factor, then you can use polynomial division to then find out your other factors. Right, so that's what you did kind of last year. Now, what is rational root theorem then? Seems like we covered it. We said sub in numbers. If it equals 0, it's a factor. To find the other factors, use polynomial division. Why is there a rational root theorem? Why do we even need that? What's the problem? What occurs that's a hint? That's when you start using rational root theorem. Very good. That's exactly it. So what's the problem with factor theorem, remainder theorem? We are assuming that because what the numbers you normally substitute in is actually the last digit. It's that last number. You find the factors of the last constant, and then you sub them in, right? So they're usually just whole numbers. It's 1, 6, 2, 3, for example, and you test them in to see if you get a 0. But who says it has to be an integer? It could be a rational, which is fraction. So you could have had a linear factor, doesn't have to be x minus a. What if the factor was something like 2x minus 1? In that case, you'd be substituting half into the polynomial. So because we haven't guessed what the value could be in terms of a fraction, that's why they're saying, well, have you tested fractions? That's why it's called rational root theorem. Okay? So how does it work? Very simple idea, same idea again. You're still looking for that 0, just like a factor theorem. The only difference is, well, it could be a fraction, and let's say it's alpha over beta. Okay, we're substituting in. The reason why it's alpha over beta is because we're saying, what if this is your factor? So it could be 2x plus 1 as an example. 2 is the coefficient of x, and then 1 could be the alpha. What you'll find is that if you look at it overall, that in front of x is responsible for the coefficient at the very front of the first term. Okay? And then a is got to be a factor of the last term, just logically. Yeah, because the only way to get that last number is when you expand the brackets. I'll do an example here. If I did 2x plus 1 times 3x minus 1, can you see when we expand that, 1 and 1 will give you that final constant term, whereas 2x and 3x will give you that 6x squared. So of course 2x has to be a factor of 6, and this 3 has to be a factor of the 6. So that's why we're saying this beta term, whatever that is, it must be a prime factor. So right here, prime, it needs to be a prime factor of the first term. And then alpha must be the result of the factor of the last term. That's what you did with quadratics. Now it's the same with cubics, and then the same thing with polynomials. Right? So today's lesson, in the next example, I'm going to show you how rational root theorem works. But rational root theorem will also cover pretty much factor theorem as well. Okay, so we'll have the whole numbers and it has fractions. So go to the next example just so that it makes a bit more sense to you now. Let's have a look at this. I already told you you're going to use rational root theorem. Okay, I even typed out all the possible rationals that you could have here. Can you see how that's 6? Normally what you would have done is you would have tested the factors of 6. Right? Now, we want the prime factors of 6. Now, factors of 6 are 1, 2, 3, and 6. What are my prime factors? Yeah. Same thing with the 12. Okay, so AN. 12 factors of 12 is 1, 2, 3, 4, 6, and 12. But again, we want prime factors. So hence, I wrote there. So that means beta, could be 1, 2, or 3. What we're saying in the theory is that you're going to sub in. Wait, is that right? Did I type that wrong? I did type that wrong. Whoops. That should be negative alpha on beta. It's okay, you get the idea. The idea is that you are now rewriting it all in terms of what if you had each different numbers. So you could have this divided by this. It could be this divided by this. It could this divided by this. But what you see is you do get a mix of integers, which is what Joe was saying before. What if you get just whole numbers? But what if the whole numbers don't work? Then what about fractions? Can you see how this is essentially testing plus or minus 1? This is essentially testing plus or minus 2. This is essentially testing plus or minus 3, which are all factors of 6 that you would have tried to see if it's going to equal that or not. But then if you rearrange that, well, it didn't have to be 1 over 1. It could have been 1 over 2 or 1 over 3. And again, you haven't tested half or negative half. You haven't tested a third or negative a third. And then same thing, what about it being 3 over 2? So you could have 3 over 2 or you can have 2 over 3. This is what rational root theorem is saying, because most of the time you're working here with remainder theorem and factor theorem, but you never considered, well, the numbers don't have to be a whole number. It can be a fraction. So that's what you would test. Now, obviously, because we know it's going to be a rational root theorem, I didn't want you guys to be subbing all these numbers in. So let's use the calculator just so that we can see where the values come out. So I'm going to use the calculator just to simplify our problem. You just need to understand the theory. Yeah. So here, let's define f of x, or technically it's p of x, is equal to, what's that? 12 times x cubed plus 20 times x squared, and what's that? Minus x minus 6. Right? Let's test it. So f of 1, so I'm testing, what if it's 1 over 1? Nah, doesn't give me 0. What about negative 1? Doesn't give me 0. What about 2? Doesn't give me 0. Doesn't give me 0. Doesn't give me 0. Doesn't give me 0. So you can fill that in. F of 1 is 25 or 3, so you can try it here. That gives you 25. What was it again? 3. 2 is 168 and negative 20, so 168, negative 20. So this is what normally happens. You try out integers and it doesn't work. This is when you know to use rational root theorem. So you try it out and you're like, okay, well, let's try 3s. That's 495 and 147. So 395, 147. P of 3, P of negative 3. Didn't work. So next, this year, when I'm teaching the year 11s, they will go through a stage where they can't test any of these numbers. Doesn't work. So what do? This is the next step. They're going to try rationals. Rational numbers. So let's try P of half. So I'm going to do P or F of half, 1 over 2. Oh, I wanted to test a bit more, but yes. happens to be that P of half gives you 0. So that tells me this is a factor. If it's going to be a factor, that means it's x, now times 2 to both sides, so it's 2x, and then plus 1, so minus 1. This is your linear factor. If you're wondering how I got the 2x minus 1, you're saying x equals half, so if you times both sides by 2, get 2x equals 1, minus 1 on both sides, and that is how I knew factor out to be 2x minus 1. Okay, because it's kind of like the reverse of null factor law. You get your factor. If it was a factor, then you would solve it for x, and you get x equals half. So I'm just going backwards from null factor law. Okay, so that gives me one factor. And so now how do you find the other factors? I've got my 2x minus 1, which is there. To find the other factors, polynomial division, and you can do it again by hand. Or if it didn't work, you keep testing until you get 0. Yeah, so from here, we can do prop frac. So actions. Where is it again? Number. So menu, number 2. Fraction tools. Proper fraction. Here we go. Let's type it in. So I got f of x divided by 2x minus 1. Yep. I think that was right. Yep. There we go. 6x squared plus 13x plus 6. So if you did your polynomial division by hand, this is your quotient. It should fit out nicely as 6x squared plus 13x plus 6. Obviously, if they ask you to find the linear factors, this is a linear factor, but this is a quadratic factor. It's not a linear factor, it's quadratic. So you would have to factorize that using quadratic techniques that you have practiced in exercise 4a. Okay, again, if you don't know how to do it on your CAS, you then say factor, bring this one down, comma x. Oops. There we go. 2x plus 3 and 3x plus 2, and that's how I got that step. So I did a CAS work just to simplify this process, otherwise it'd be very long. It's tedious, you sum in and you do it all algebraically. The point is for you to understand what rational root theorem is, yeah? And when to use it. So you use it when these whole numbers don't work, then there's a possibility that it could be a fraction. Okay? All right, team, I think that's all. Oh, there's more? Did I do? Oh, this one's a nice tricky one. Actually, turn over to this page. I'm going to pause the video here. It just looks hard, but it really isn't. Just rewrite everything again. Rewrite everything again. Same idea. The aim is to find that squared. Trying to find that square. Yes. It was to confuse you. Very good. It was. It's a distractor.
Wait, is 3 root x2 just root distractor?
You need to know what cube root is as a power. That will help you.
Wait, is that on the cube root or on the 7?
Now this is 7 times cube root of x squared. And really, we only put the cube root and the x power 0 to distract you. We could have wrote it in the correct powers, and then it would have been easy to see. And same technique, you should be able to then factorize this one. Same technique.
X to the 2/3 squared.
X squared to the power of 2/3.
It's not just like, it's not just like 1, 2, 3.
That's right.
We just did it on that side. We're supposed to do the same thing. Alex is doing exactly what we tried last time. I hate this kind of stuff.
Guys, you don't know that one.
Yeah, I was right first. I was supposed to.
Why do I keep nodding?
In the inside. Because that's you know this. You just three on the inside and the inside.
Shit, you're right.
I'll see you on Tuesday.
Oh, you just put the 2/3 in.
So until Tuesday.
No, then
Big grade.
Big version.
He should help him, and he should help you to make sure you both are on track. I'm going to check both of you on Tuesday too. Same thing.
I don't know what you
get yourselves ready. By end of year, you want to be ready. I'm just here to support you guys. I'm like a cheerleader. Don't want you to quit. It's too early to quit.
Let G and X go to 203. G squared minus 7G plus 12.
Who else was on my list?
Negative 4 and negative 3.
It was 4 students, wasn't there? Ah, it was Noah. Whoops. Is this still recording?
So I have to put it back in the roots.
I think it's recording. Alright, team, so... Oh, you want a bit more time? I'll write it and you don't have to look, okay? So I'm going to freeze the screen so you can't see it. And then I'll write the solutions. Oh, yes, I should. What was Tuesday again? 4 BC. I love it. Keeping each other on their toes.
So I think Joe needs to end in the maths.
He's a what?
He's going to end on speed up.
Unfortunately, it will make me look bad if I put people at N. And, you know, he could be a potential. What if he, you know, studies hard at the end of year and he brings up the scores, you know? The more data, the better. Joe doesn't do anything at home. You know, he's going to drag your scores down, so you better be doing something about it. What are you doing about it?
I'm studying every day.
No, what are you doing about him?
I'm supporting
Hitting him. That's good. I do believe in, you know, a bit of harsh punishments and consequences. Because without discipline, there is no order.
Yesterday he said he played Minecraft instead of studying and I punched him in the face. Punch him in the face right now. Okay, wait, I got a question. Do you think splitting the class between me and Harry and Joe and Ed?
It's obviously you and Harry. Let me know a question. Joe is holding that down.
So I don't think people outside my group rate Harry. Me and Harry versus Joe and Ed. I think he rates Harry. So I think he's
Very close fight, actually. So Amos, what's the matchup? Joe versus Alex.
Why would we be versus Alex? It'd be a me versus Alex.
Oh shit.
You think Joe's better than Alex?
No, Alex is funny. 20 I could do it on paper, right?
I was into 2v2. I can just possibly be up.
Come on, say the names. It's in code.
Alex and Harry.
Joe and Ed.
So Joe's.
No, Eamon up there. Why would Joe versus Alex?
Whoops. It's still recording.
You guys got this all wrong.
What?
Alex is saying that.
But you think even Joe's better than Eamon in a fight?
Yeah.
That's crazy. Are you just kidding?
Joe's got the power to like do some like weird.
Oh my god, he's not glazing.
Joe's good at jumps though.
It's just a fight. It's like a street fight. Like you see each other on the street from different gangs. Like from the groups that
I feel like Alex would be posing all the time and still running like full at them. So that's like how I imagine it. I don't see Alex winning.
All right, you guys ready for the answers? All right, here we go. Unfreeze the screen.
Joe versus Eamon in a fight.
Like this is a joke for both Alex.
Show of hands who got that if you did attempt. Well done. Little trick was to find the square.
Wait, like fully upside down. No? What? It means shoulders.
Quadratic. There you go, Joe. Did you get it right?
No.
You You said it so quick. Did you even look at it?
Yeah, I don't know. I don't know what right.
So ask if Big Ray will right.
So I just changed it to make it a quadratic.
I got right.
So 4/3. This is 4/3, which is a third. Times together is 2/3, 2 over 3. And then I thought about that. I'm like, can I make it 2 over 3? You can. 2 over 3 times 2. So then that means let that equal A. So you got A squared minus 7A plus 12. That's easier to factorize. This is 3 negative 4. And then resubstitute A back in.
Not all of